welcome to our channel Euclid Mathematics. We have started lecture series on GATE previous year question paper. Within that, I already uploaded plenty of the videos from the previous year GATE question paper. So all of these questions are latest question from previous year GATE exam. So if you wanted to see more videos similar like this, you may check it into my playlist. Now in my today's video, I'm going to explain to you one of the question from GATE Mathematics. It is a very easy question that we have to find out the only determinant and some need to apply some result over here. Okay, now let's get started on today's question. First of all, I'm going to explain to you all question and then we'll move for the detailed understanding of solution. Our question, it says that we have matrix M which having entry 1 1 0 0 1 1 0 0 1. Okay, and e to the power m is given id plus m. Id means identity matrix, 3 by 3 identity matrix with multiplied by d. M plus 1 by 2 factorial m square plus 1 by 3 factorial m cube plus so on. Okay, if e to the power m is given also bij, the matrix bij. Okay, so matrix bi e to the power m is having element like a matrix bij, then we want the value for 1 upon e, I is equal to 1 to 3, ij is equal to 1 to 3 bij. Okay, and then we want the what the value it is coming. Okay, so this question is a no answer type question, so we have to find out the fill in the blank over here. Okay, now let's see how the solution look like. We'll go for the detailed understanding of our today's solution. Question, m matrix m, it is given 1 1 0 0 1 1 0 0 1. Okay, and I written this matrix M as identity matrix plus this matrix. Okay, so I just expanded matrix M this way. Okay, because I have to find out some relation is there exists inside M or not. Okay, and that I have to compare this relation with e raised to m. Okay, then we'll get the bij easily. Okay, so m I written as identity plus matrix, some other matrix. Okay, so consider any matrix here as a. Okay, so M matrix I written here identity matrix plus A. Okay, so I consider this matrix as A. Okay, M is equal to identity plus A matrix. That means we have exponential term e to the power m. That means e to the power m can be written as e to the power m can be written as e to the power identity plus A. Okay, so I replace m by identity plus A, so I expanded e to the power m as e to the power identity plus A. So let's expand this one, e to the power identity plus A, that can be written as e to the power identity into e to the power A. Okay, so e to the power m I written this way, e to the power identity into e to the power A. Okay, so we know that expansion for e to the power x, what is the expansion for e to the power x? Like 1 plus x square by 2 factorial plus x cube by 3 factorial plus x to the power 4 by 4 factorial and plus so on. Okay, and this is the expansion for e to the power x. Okay, so e to the power x compare with e raised to I, so what will get the e raised to I expansion? Replace x by I, 1 plus I square by 2 factorial plus identity cube by 3 factorial plus so on. Okay, this way I expanded e raised to I. Okay, so simplified more further, so take identity. So if I have identity matrix as a 1 0 0 1, if I'm going to find identity square, we'll get the identity itself. If I found identity cube, which is equal to identity square, which is equal to identity, that means the value for identity to the power n, which is only itself identity. Okay, that means 1 plus I identity square again identity cube again identity. So I can write this as 1 plus I plus I square by 2 I by 2 factorial plus I cube by 3 factorial I by 3 factorial plus 1. Okay, so I replace I square by I cube by I. Okay, and plus 1. So take identity matrix common from here. Okay, so 1 means 1 into I it is there. Okay, so identity common here, 1 plus, so 1 plus identity common from here again, 1 plus 1 by 2 factorial plus 1 by 3 factorial plus so on. Okay, and here we can see this is the expansion of e raised to 1. Okay, so the e raised to 1 can be written as e raised to 1 here 1 plus 1 plus 1 square by 2 factorial, 1 cube by 3 factorial, 1 cube 4 by 4 factorial. So this is the expansion for e raised to 1. Okay, so identity into e raised to 1. That means we got the matrix here 3 by 3 matrix, so which is diagonal entry identity, a non-diagonal 0, because we multiplied identity to the e to the power 1. Okay, so I got the e raised to I matrix this way. Okay, so I got the e raised to I matrix this way. Now I want the I got the matrix e raised to I over here. Now I want the again e raised to a matrix. Okay, so e raised to a can be written as e raised to a, right? E raised to a here similar way, 1 plus a square by 2 factorial, a cube by 3 factorial. So 1 plus a square by 2 factorial plus a cube by 3 factorial plus 1. Okay, this is the expansion for e raised to a. So find out the a square by 2 factorial, a cube by 3 factorial. Okay, so you need to find out their power. So here we can see, as we did in my answer. Okay, so I expanded this matrix over here, written m is equal to a into I identity plus a. So e raised to m can be written as e raised to I plus a. So this one written over here. So first I work the value for e raised to I, e raised to I, then here it is the value for e raised to I, then we want the e raised to value a. Okay, e raised to the value of a. So the matrix A we have here, I consider a matrix this way. Okay, then e raised a, it is there, then a square we get this one, a cube we get the complete 0 matrix. If a cube is 0, then a raised to 4 0, a raised to 5 0, a raised to n 0, but which cannot say that a square is 0. Okay, so we have a square non-zero, a cube here. Now we want the value for e raised to a. Okay, so 1 plus a, so a matrix over here, plus a square by 2 factorial, that means this matrix multiplied by 1 upon 2 factorial, plus a cube multiplied by 1 upon 3 factorial, a raised to 4 multiplied by 1 upon 4 factorial. But it seems like that after these terms we have all matrix 0. So if you multiply anything to the 0, you will get the 0. Okay, so after this we have 0 matrix. So we have to deal only these three terms, 1 plus a square by 2 factorial. Okay, now let us solve, we will solve this first part over here. Okay, and then we'll figure it out how the values are coming. So as I explained earlier, these terms are looking like this. Okay, so 1 plus a square by 2 factorial plus another term 0. Okay, so add their corresponding element 1 plus 0 1, 0 plus 1 1, 0 plus 0 plus 1. Okay, so 1 means here 1 by 2 factorial here, that means 1 by 2 here. Okay, 0 plus 0 plus 0, all 0, again 1 plus 0 plus 0 0, 1 plus 0 1, again 0 0 1. Okay, so I got the e raised to a matrix this way. Okay, I got the e raised to a. So I'm having e raised to m, I got the e raised to m as e raised to identity and e raised to a. Now put e raised to identity this way, e raised to a here we have here. Okay, now multiply these two matrix, e raised to m will get it here. And we have given e raised to m is a bij matrix. Okay, so e raised to m is the multiplication of these two, I got it here. Okay, which is a matrix bij. Okay, so I got the value for bij. Now I want the value for 1 upon a, I is equal to 1 to 3 summation j is equal to 1 to 3 bij we want. Okay, that means we have to run I 1 to 3 and j 1 to 3. That means run I 1 to 3 when I is equal to 1 to 3, b1 b2 b3 coming, j is equal to 1 to 3, j1 j2 j3 coming. Okay, that means b11 b22 b33. Okay, so all three values for I, then again j, then their combination. Okay, so first of all, if you want, you may first of all find out this series and then apply this one. Okay, so you will get this step. So 1 upon e as it is over here. Okay, 1 upon e as it is here, this is the expansion of that series over here. Okay, so how can we find the how I found this one? Run j is equal to 1 to 3. So bi1 plus bi2 plus bi3, then run I is equal to 1 to 3. So b11 b12 b13 b21 b22 b23. Okay, similarly 31 and 32 over here. Okay, so these all are the values for b b11, b22, b33. Okay, now we want the value for b11. So how can we get the value for b11? So first value, it is the matrix bij. Okay, so this is the value for b11, b12, b13, b21, b22, b23, b31, b32, b33. Okay, these all are the values here for our corresponding elements. Okay, now substitute all these values over here. Okay, and find out what is the addition it is coming. Okay, so here we can see 1 upon e as it is. So b11, b22, b33. Okay, 11, 22, 33. Their addition is 3 times e. Okay, b12, 1, 1, 2, 1, 2. Okay, so that means we have to add all the terms over here. Okay, so 5e plus e by 2, e by 2 which is coming. Okay, so it is very easy additions. So 1 upon e under bracket 5e plus e by 2. Okay, now multiply 1 upon e under bracket. Okay, so 1 upon e multiplied by 5e, so it e get cancelled, remain 5. 1 upon e multiplied by e by 2. Okay, so e will be get cancelled, so 5 plus 1 by 2. Okay, so 2 5 2s are 10 plus 1 11 by 2, so we'll get the 11 by 2 and our required answer is a 5.5. Okay, now see what we have done. First of all, I found the value for e raised to m. Okay, e raised to m means I expanded m matrix as identity plus some another matrix. Okay, so e raised to m matrix I expanded as e raised to I plus e raised to a. Okay, so e raised to I plus a I expanded there. I found the value for e raised to I, then I found the value for e raised to a. After getting these values, I got the value for e raised to m as a bij, and after of getting all these values, I substitute these values here in our summation. Okay, and then at the end I got the value for our summation over here, which is a 5.5. Okay, the question it is completely easy, and that we have to apply the exponential term e raised to x. You all need to be familiar with the e raised to x. Okay, that concept you have to apply. So I hope you all have understood everything of my today's lecture. Nothing is difficult here, which is a very easy calculation, and need to find out the values for e raised to m, and then the no answer type answer question it is here. Okay, so I hope everything is easy here, so you all have understood everything. Even after, if you found anything difficult, let me know in comment section. I will come up with some other videos. So thank you everyone, thank you for my today's lecture.